All right, guys, we're going to launch into lesson 8-5, and we're going to be now talking about undoing all the things we just learned in the first 4 lessons. So I was thinking about giving you guys a little review about the lessons 1 through 4 and seeing how well that you were getting this down. But Mr. Johnson and I were talking about we're going to wait till we come back on the 20th. Well, not on the 20th, but that week we will definitely do something. And so, again, this book is kind of built that the first 4 lessons are about multiplying and getting rid of parentheses, and the second part of the chapter is about going backwards and putting the parentheses back in by factoring. All right, so let's go ahead and review a couple terms. First one is the word of factoring. So we've talked about factoring before, but it's been a while. So factoring, oh, that's supposed to be, there we go. I don't know why that was so thin. That's highlighter. So factoring is rewriting a polynomial, so could have anywhere between 2 or more terms, as the product, a multiplication problem, of its factors. Okay, and those are the 2 things that are being multiplied, okay? So the one thing that you're going to hear me say a lot is factor, I don't even know where I was going with that one. Let's try that again. Factored completely. That means you need to look at your binomials, because that's how we're going to factor into binomials. In some cases, in other cases, we'll factor out maybe a monomial, and then what's behind is a trinomial that then we will factor that into binomials. So you got to keep asking yourself, is there something more I can do? Okay, so that's going to be the toughest part of this whole section. So what we look for when we're factoring is we start with a GCMF. Okay, GCMF. And the GCMF is the greatest, there's your G, common, there's your C, and you're like, yeah, I got those. I got F for factor, but what's that M? Well, that is monomial. So if you remember the definition of a monomial, it can be a number, a variable, or a combination of numbers and variables. Okay, so now what we're looking for is not just a coefficient that they all share in common, but we're also looking for a variable they could all have in common. Okay, so this is the first thing we do, and I'm going to be honest with you, it's the last thing you think to do. It just is. Okay, it's the first thing you need to think about when you're factoring. So first term we look for when factoring. Super important. Oops. Okay. Very important we look for that GCMF. So just as a reiteration, that it can have numbers and or variables. I'm going to say variable and then in parentheses S, because it could be more than one variable that they have in common, that all terms have in common. Oops, kind of did a little too much flourishing there. All right, so let's do a couple of examples, and I'm going to use a technique that I think is brilliant, actually. I don't know if it has an official name. I've heard a lot of teacher names for it. So we have, let's see, 27y squared plus 18y. And this is I've heard it called the upside down wedding cake. I've heard it called the ladder. I think I kind of go with the ladder. But basically what you're going to do is you're going to take this guy and you are going to start looking for common factors. Now, you don't have to look for the greatest common factor to begin with, but you got to look for something. So, for example, 27 and 18, I know 3 goes into both of those. So, when I divide out 3, oh, I don't like that color, sorry. See, 3 goes into 27 9 times, you get 9y squared, plus 3 goes into 18 6 times, and you get 6y. But I notice there's another stinky 3 hiding out in 9 and 6. I'm going to take out another 3. So 9y squared divided by 3 is 3y squared, plus 6y divided by 3 is 2y. Now, coefficient-wise, I don't have anything in common, but variable-wise, I do. So I am limited to pulling out the smallest exponent on a common factor. Why? Well, if I have y squared and y, I can't pull out a y and a y from a single y. So I'm going to pull out a y, and that's going to give me, let's go with 3y, because y squared divided by y is y, and 2 is going to remain, and y divided by y is 1. Now, what I'm going to do is I'm going to tell you that these guys all on the outside are your GCMF. So I take those, GCMF, and I'm going to multiply them together, and I get 9y. All right? So how do I write the answer? I'm going to move over here, and I'm going to write it this way. GCMF, and then it's going to be times the remaining polynomial. And in our case, it's a binomial. That's the format that we will always take with this. So for our answer, we're going to get 9y times the quantity, and then it's just sitting right there at the bottom, 3y plus 2. And there's your answer, okay? So I'm going to write out what I had said before. The lowest exponent on a common variable is the greatest common exponent. So the smallest exponent is the biggest thing that we can pull out, okay? And then you do need to ask yourself, can I factor more? It's always the question you got to ask. Now, it's going to kind of slowly creep in on us. All right, then we have another one. We have negative 4a squared b minus 8ab squared. Sorry for the big gap. Let me erase that and have the b next to its a. Boop. There we go. And then plus 2. Ooh. Let's try that again. Plus 2ab. So, I'm going to show you a second way of showing this. So what you can do is kind of think about, well, let me think, what can I pull out? So I'm going to look at one thing. Oh, sorry, I wrote that wrong. I thought that looked weird. That's why I had so much room here. Because my a actually has an exponent of 2. Okay, all right, there we go. So let's look at the coefficients. And then just to let you know, there's 2 ways to write this answer. Way 1 is, a lot of times we don't like in parentheses to see a negative. So I'm going to pretend I'm just going to leave the negative where it's at, but I'm going to show you how to write the answer a second way as well. Okay, so I'm looking at -4, -8, and +2. Well, I know they all have a 2 in common, so toot in common, that sounds funny. So I'm going to pull out a 2 from each of them. Okay? Then I'm going to look at their a's. So I have an a squared, I have an a, and then I have an a. So the biggest amount of a's I can pull out is only 1. So I'm going to pull out an a, and then let's see, we have a b squared, we can b. So the smallest exponent, b, is all that I can pull out. Okay? So that guy is your GCMF. Okay? So he is the GCMF. So let's pull him out in front. I'm just going to make him solid green, 2AB. And then when I like it doing this way too, because you can see when you put all the stuff underneath, you can see what the individual little problems are. So -4 divided by 2 is going to give me a -2, and then an a squared divided by an a is going to give me an a, and a b divided by a b is going to give me 1, so I don't need to show it. And then -8 divided by 2 is going to give me a 4. A divided by a is 1, so I don't have to write it. B squared divided by b is going to give me a b. And then plus 2 divided by 2 is going to give me a 1. A divided by a is going to give me a 1. B divided by b is going to give me a 1. So 1 times 1 times 1 is 1. Okay? And that would be my answer. Now, before I do anything else, I do want to write this note. There should be the same number of terms in the parentheses as you started with. So the original polynomial had 3 terms. So that means I better show up 3 terms in my parentheses. And that guy right there at the end, that 2ab divided by 2ab, gets dropped off. And you take that trinomial and all of a sudden he becomes a binomial. That doesn't happen when you're pulling out a monomial. The polynomial is not going to change its length when you pull out a polynomial. Okay, so what was the other way I could write this answer? Pull that negative out. So it'd be -2ab, and then that's going to change all the signs inside. So 2a plus 4b minus 1. So either one of those answers is good. Okay. All right, so let's get into why this idea of factoring is so important. And we're going to introduce you to the very first way that we are going to factor polynomials. So this is my second page, so I'm going to title it again, Lesson 8-5, using the distributive property. See, he's so important. To factor. Again, 4/9/2020. Okay. So, super duper important guy. Let's make him orange. Factoring by grouping. Factoring by grouping. Now, factoring by grouping has a specific condition that needs to be met. Number 1, there needs to be 4 or more terms in the polynomial. Now, what's going to be funny is I am going to use this technique again in the chapter, but I don't have a 4-term polynomial. What I'm going to do is create one. So we're going to learn to factor almost every type of polynomial using this strategy, okay? So 4 more terms in the polynomial, but, so big but, they must group into 2 groups I'm telling you, some of my writing is really bad. It's been a long day. patience of saints my kids had today who came in. Thank you. That each have the same GCMF, and then, are you ready for it? Magic happens. Big magic, okay? Now, does that mean factoring by grouping works every single time? No, it doesn't, okay? So let's introduce it and let's practice it a little bit. So we're going to go real simply. We have AX plus BX plus AY plus BY. So the question is there something that I can pull out? Oh, no, they don't have the same GCMF. Have a GCMF, and then magic happens. So the funny thing is, what I notice about my terms here is I have two x's side by side and I have two y's. So I could group them by x's and y's. But if I rearranged this problem, I have two terms that have a's and two terms that have b's. Now, if I look at a problem and side by side I see something that is a GCMF for each one of those pairs, then I don't mess around with rearranging things. There's other times I do rearrange. Okay, so this is something just that we're going to play with. So these guys both have an x in common, so that's going to give me x times the quantity, a plus b. And then it is a plus sign in the middle, so we're going to be pulling out a positive. And then the second grouping have a y in common, so that's their GCMF. And are you ready for it? Here comes the magic. I have A plus B left behind. That's what we want to happen. We want that binomial to be the same for both. So technically, what I'm doing in my next step is I'm going to divide out the binomial from each of these. So it's can't throw out because it's actually this guy, but this is what I'm doing to kind of see it, right? So what's left behind, x times a plus b divided by a plus b is x. Y times a plus b divided by a plus b is y. There you go. You get two binomials as the result of factoring, okay? So, end result, no, this is generally, because remember what I had given you and something to think about, that you always need to look at your resulting binomials and see if there's something more you can do. Okay, a lot of times we forget to pull out the GCMF that all of them have in common. Excuse me. So that becomes something we have to pull out down the line. So the end result generally is going to be the product of two binomials. Product of two binomials. Okay, so let's see if we can practice. I may need to go onto a third screen. We'll see. But it should fit for you guys all on one page. So the directions are to factor. I'm going to remind you. Well, let me just do a different color. Remember to look for a GCMF first. Again, this is something that we really have to train our minds to do, okay? So here's our first problem. And I'm going to call it first because these are kind of like separate lessons. We have 4QR plus 8R plus 3Q plus 6. So again, what I don't want you guys doing is like, oh, do I need to rearrange these and really kind of, noodle your way through this. Just look at the two that are side by side. What do you see that they have in common? Well, coefficient-wise, they have a 4. Variable-wise, they have an r. So let's see what that gets us. 4r times the quantity. Well, 4 divided by 4 is 1. QR divided by r is q. And then we have a plus. And then what do these two guys have in common? Excuse me, my throat is a frog. And we're going to pull out a positive 3. Oops, sorry. He was a 2 there. My brain. It's a long day. Sorry, guys. There we go. That makes more sense. We get a binomial. Let's try this again. So then we pull out the positive 3. And 3q divided by 3 is q. And 6 divided by 3 is 2. The magic happens. Woo! So I'm not going to divide by that, but I'm going to recognize the common factor of g plus q. So my answer is g plus q, and then it's going to be taking those coefficients I pulled out, those GCMFs, and they become their own binomial. Now I double check q, 2, nothing in common, 4, r, and 3, and I'm done with that problem. Okay, let's try another one. Let's see, we have Rn plus 5n minus r minus 5. Okay. So, here's where it gets a little tricky. This guy right here messes us all up. And this is going to be the challenging ones for you guys, okay? And down the line, I'll talk to you about some other things that you can do to solve this problem. But let's just deal with this the way it is. So let's look at the first two. I definitely see something they have in common. They both have an n. So I'm going to divide out an n, and that's going to give me n times the quantity r plus 5. Now, when I have a negative, I need to divide out a negative from each of those terms. So that's where it gets a little tricky. And negative r divided by negative 1 is positive r. Negative 5 divided by negative 1 is positive 5. Okay? Sometimes we have to do, there's some weird things that happen that we have to kind of play around with, but there's your miracle. You got your magic happening. So then we're going to factor out the binomial r plus 5, and then the remaining coefficients are going to, the remaining factors make their own binomial. So we have r plus 5 times n plus 1. Again, nothing that I can factor out, so that's my answer. Okay, now, sometimes I have actually counseled students to try doing the problem this way. Avoid that negative in the middle. How? Rearrange your terms. As long as you have two terms next to each other, that looks like a big weird M, so let me try that again. Rearrange and put that negative r here, and then you have a positive 5n minus 5. So when I factor by grouping, r here, 5 here, so I'm going to get r times the quantity n minus 1 plus 5 times the quantity n minus 1. So that kind of eliminates the issue we were seeing with having to pull out that negative 1. So your final answer would be n minus 1 times r plus 5. So it's the same exact binomials. But the commutative property says, doesn't matter the order that you multiply, the answer is going to be the same. So that's just it. So you feel more comfortable rearranging, you can rearrange, okay? But you can't rearrange to the point where you got nothing you can pull out. But sometimes actually you do have nothing you can pull out. So the common factor is a 1. All right, let's try this next one. 3p minus 2p squared minus 18p plus 27. So first thing I'm going to suggest is that if you see something that looks like this, I would go ahead and rearrange and put it in standard form. So that would put, actually no, you know what? I take that back. Let's just deal with it the way it is, and then I'll show you something you can do. There. Change my mind again. What do these guys have in common? A p. Now, here's where you got to watch out for, okay? What you have to watch out for is what we're going to pull out next, okay? And we got to pull out, don't forget, we've got a negative, okay? So what I'm going to pull out here is going to be a negative. Let's see what goes into both of them. It's going to be 9. So I'm going to pull out a negative 9 from each of them. So that gives me p times the quantity, 3 minus 2p. And then minus 9 times the quantity, let's see, positive 2p minus 3. Now, did we get the magic? Ah, we're so close. The terms are the same, but their signs are opposites. So, wait a second. I can do something about that. Tell you what I can do. I can divide out a negative 1. If I divide out a negative 1 from this guy and from this guy, I'm going to get a negative 2p, matches, and a positive 3, matches. But what am I going to do with this negative? I'm going to make him multiply with the negative that's above him. Ooh-wee! Did I just blow your minds? That's math for you, my friends. That's math for you. So we've got 3 minus 2p, and then we're going to get a plus 9. But now what happens, I don't like to see a negative first thing, so now that makes the 3 the positive number and the 2p the negative number. Did we get our magic happening? Absolutely. So then we get 3 minus 2p. I divide them out, and what I'm left with are my 2 factors, the GCMFs, p plus 9. Okay? Can't pull anything out from either one of those, so there's my answer. Now, what I want you to do is to think about, since I have some room up here, what if I did do what I thought? What if I did this? What if I rearranged them into, oh, so that's a p there, into standard form? And I factored it this way. Well, let's see, they have a negative p, and these guys have a negative 9. Let's see what that does. Do I still mess myself up? Let's see. So I have negative p times a 2p minus 3. And then if I pull out a negative 9, that's going to give me a, I'm gonna have to scrunch it. That's too scrunchy. I'm going to have to go down this way. And minus 9, oh no, that whole thing is bad. I just did not give myself enough room. Okay, let's see, how can I do this? Let's do it this way. Minus 2p minus 3. So the 2p minus 3, sorry, minus 9. So I get a negative p, take away 9, and a 2p minus 3. Notice what I did here? I pulled the coefficients out first. No problem. Now, does that look exactly like the answer I have? No. So what would I need to do? Oh, if I pulled out a negative 1, That would give me a p plus q times a 2p minus 3. All right, does that match what we have? Nope, but guess what? What if I distributed? So there's so many ways to play with this stuff, guys. So we get p plus q and 3 minus 2p. So we get the exact same answer. Okay, I am going to have to go to the next screen for my next problem. Okay, and my last problem. Oops, sorry. So number 4, we have c minus 2cd plus 8d minus 4. We're going to group them like we've been grouping. Those two have a c in common. These two have a, let's see, a 4 in common, a positive 4. So I get c times the quantity 1 minus 2d, and then I get plus 4, sorry, I should change that to blue. Times the quantity 2d minus 1. Okay, so notice I ended up getting the same terms, but they are opposite signs. So what I'm going to do is I am going to pull out for this guy a negative 1. So he's going to become negative 1. That makes 2d negative and negative 1 positive. Okay, so what do I do with him? I multiply him up there. At this point, I've got c times the quantity minus 2d minus 4 times the quantity 1 minus 2d. So I factor out the common 1 minus 2d and multiply it by the c minus 4. And there you go. All right, let's get crack-a-lacking on the practice. All right, guys, good luck with this. Bye-bye now.